All right, let's jump into a paper that's really pushing the boundaries of how we think about LLM reasoning. We're diving into ReasonFlux. It's not just solving complex math problems. It's doing it with a level of planning, almost like strategic planning. That's pretty amazing to see.
Yeah, it's really mind-blowing when you dig into how it actually works. The paper itself is called ReasonFlux, Hierarchical LLM Reasoning via Scaling Thought Templates. And it's by Ling Yang and a team over at Princeton and Peking University. The really fascinating thing here is, instead of just throwing more data at the problem, they've really found a way to structure knowledge in a way that makes it much easier for the model to actually reason effectively.
So for those of you who haven't gotten a chance to read the paper yet, the core idea here is that ReasonFlux uses a library of these thought templates, which are basically predefined blueprints for solving specific types of problems. You can almost think of it as a toolbox filled with these proven strategies. And the model learns to select and chain these templates together to sort of create this dynamic reasoning plan.
Right. And the results are really speaking for themselves. They're achieving state-of-the-art accuracy on some of the most challenging math reasoning benchmarks out there. The math data set, for example, they hit 91.2% accuracy. And on the USA Math Olympiad, AIME, they're solving over 56% of the problems. That's, to put that in perspective, that's significantly better than even some of the most powerful LLMs that we've seen, like OpenAI's O1 preview.
What's particularly interesting to me is that this approach seems to be, pretty generalizable. They show in the paper that it works well with different base LLMs, which suggests, that it's not just this one-off trick that's tied to a specific architecture. And that has some pretty, major implications, I think, for anyone who's working on improving LLM reasoning across a wide range of tasks.
Absolutely. The paper goes beyond, simply presenting this new model. It really offers like a potential paradigm shift in how we're thinking about LLM design. By structuring knowledge in a more organized way, we might finally be, cracking the code on how to make these models more efficient and more powerful reasoners, moving away from this, black box and towards a more transparent and explainable AI. And I think if you're at all in the field of AI research or development, it's definitely a paper you should check out.
So, let's dive a little bit deeper into the problem that ReasonFlux is actually addressing. Both of you have worked extensively with LLMs. What are some of the biggest challenges, when it comes to getting these models to reason effectively, particularly in a domain like mathematics?
Well, one of the biggest hurdles, I think, is that current LLMs, even the most advanced ones, they often struggle with these complex reasoning tasks that require like a step-by-step approach. They might excel at things like pattern recognition or language generation, but when it comes to problems that really need this structured, logical approach, they tend to sort of hit a wall.
Yeah, it's like they're missing that crucial element of strategic planning that, we humans, we just kind of take for granted. They might have access to these vast amounts of information, but they don't necessarily know how to apply that information in a systematic way to actually solve a problem.
Exactly. And that's where I think a lot of existing methods for improving reasoning, like tree of thoughts or reward model-guided search, they often fall short. These methods can be really computationally expensive, and they may not always generalize well to, diverse problem types.
Right. So how does ReasonFlux actually manage to overcome these limitations? What's the secret sauce, so to speak?
Well, I think it all starts with this really brilliant idea of using this structured library of thought templates. So instead of treating all knowledge as, this massive unstructured blob of text, ReasonFlux breaks it down into these predefined templates. And each one of those templates encapsulates, a proven problem-solving technique. They give examples in the paper like trigonometric substitution or the inequality of arithmetic and geometric means.
So they're essentially giving the model a more organized way to access and apply relevant knowledge, which seems like a far more intuitive approach than, just hoping the model is going to magically figure out how to structure its thoughts on its own, right?
Exactly. And this structured approach has, a couple of key advantages. First, it makes knowledge retrieval far more efficient. Instead of having to, sift through this giant haystack of information every time it encounters a problem, the model has this kind of mental map that leads it directly to the relevant tools.
It's almost like, the difference between searching for a specific book in a completely disorganized library versus having this, really well-organized card catalog that points you right to the shelf and call number.
That's a great analogy. And secondly, this structured approach can also really aid in generalization. Because the model is learning to apply these templates to, a variety of problems, It's essentially developing this deeper understanding of the underlying principles and strategies, and those can then be transferred to, new situations.
So it's not just about memorizing solutions, it's about learning to reason strategically, which is, a pretty big deal in the world of AI. But having the right tools is only part of the story, right? You also need to know how to use them effectively. And I think that's where this hierarchical reinforcement learning comes into play.
Yeah, absolutely. The model is trained using this hierarchical approach to learn how to chain these thought templates together, in the most effective way for a given problem. It's essentially learning to create this dynamic reasoning plan, adapting its strategy based on, the specific challenges it faces.
So it's not just rigidly following, a script. It's learning to sort of think on its feet and adjust its approach as needed. And this is where I think it starts to get really intriguing. During inference, when the model is actually solving a problem, ReasonFlux analyzes the problem, it retrieves the relevant templates, and then it actually guides a separate inference LLM through the steps that are outlined in those chosen templates. It's almost like having a seasoned architect handing over a blueprint to a construction team, but also kind of being on site to provide guidance and make sure that everything goes according to plan.
Yeah. I like that analogy. And what's even cooler, I think, is that this iterative process, allows for those dynamic adjustments along the way. So if the initial plan isn't working, the model can actually reevaluate and adjust the template trajectory based on those intermediate results.
So it's not just, blindly following this predetermined path. It's constantly analyzing the situation and making course corrections as needed. This level of adaptability is, I think, pretty remarkable, especially when you compare it to some of the more rigid approaches that we've seen in the past.
Yeah. It really starts to resemble, the way that humans approach this complex problem solving, that ability to iterate, to refine, to adapt based on feedback and new information.
Speaking of feedback, let's talk about results. Does this fancy template-based approach actually translate into better performance?
Oh, absolutely. The results are, they're really quite impressive. As we mentioned earlier, ReasonFlux achieves state-of-the-art accuracy on some of, the toughest math reasoning benchmarks out there.
Okay, give us some numbers. Our listeners are always eager to see how these models stack up against the competition.
All right, so for example, on the math benchmark, it reaches an accuracy of 91.2%. And that's significantly better than, even some of the most powerful LLMs like OpenAI's O1 preview, which it actually outperforms by a margin of 6.7%.
Wow, that's a serious jump in performance.
Yeah.
What about the USA Math Olympiad? How does it fare on, that notoriously difficult benchmark?
So on the A piece, ReasonFlux solves an average of 56.7% of the problems. And again, it surpasses both O1 Preview and DeepSeek V3 by substantial margins.
Okay. That's seriously impressive. It really, highlights the power of this structured hierarchical approach to reasoning.
And what's particularly encouraging, I think, is that this approach seems to have, strong generalizability. The authors demonstrate that it can be applied to different base LLMs, and it still leads to, pretty significant improvements.
So it's not just this one-trick pony that's, tied to a specific model architecture. That's a very promising sign, I think. I'm curious, is there a specific example in the paper that really made you go, aha, this is what sets ReasonFlux apart?
Yes. There's a great example in Figure 3 where they actually compare, how O1 Mini, which is a fairly powerful LLM, struggles to solve this complex problem, while ReasonFlux tackles it with, this elegant strategic solution using these, thoughtfully chosen templates. And it really, I think, visually demonstrates the power of ReasonFlux's approach.
Oh, yeah. I love those aha moments when, a complex concept suddenly clicks into place. It's like, finding that missing piece of a puzzle. And speaking of puzzle pieces, there's one more detail I wanted to touch on before we move on. What really stood out to you as particularly intriguing?
One detail that really fascinated me was how ReasonFlux doesn't just blindly follow, this fixed sequence of templates. It has this, what they call an interplay mechanism, and it allows it to sort of reevaluate its plan and adjust the template trajectory based on, the intermediate results, as you can see in Figure 4. And this adaptability, I think, makes even more powerful and, almost human-like in its reasoning abilities.
It's like having, the flexibility to sort of course correct mid-flight instead of being locked into, this pre-programmed trajectory, this level of dynamic reasoning opens up, a whole world of possibilities, I think, not just in mathematics, but potentially in any field where, strategic planning and adaptation are key. But before we get too far ahead of ourselves, let's maybe take a moment to, digest what we've learned so far, and then we'll come back to explore, some of the wider implications of this research.
That interplay mechanism you mentioned, I mean, that's really a game changer. It suggests that these models are becoming more than just, static processors of information. It seems like they're developing a capacity for, dynamic, real-time adaptation, which is like a hallmark of true intelligence, isn't it?
Yeah, it's like you're beginning to think more, like we do, constantly reevaluating, adjusting, learning from experience. So maybe zooming out a little bit, what are the bigger implications of this research? Where do you see this heading?
Well, I think this paper opens up, some really exciting avenues for the future of LLMs. This whole combination of structured knowledge and hierarchical learning could be transformative for such a wide range of AI applications. It's not just about math problems anymore. It feels like it's about unlocking this, whole new level of reasoning capabilities across so many diverse domains.
Let's maybe unpack that a little bit. What specifically about this structured knowledge approach is so revolutionary? I mean, we've been training LLMs on, these massive text data sets for years. What's different here?
Well, I think the key difference is really in, how we're presenting knowledge to the model. Traditionally, LLMs have been trained on, vast amounts of unstructured text. They're basically learning to predict the next word in a sequence. And while this statistical approach can be remarkably effective for certain tasks like text generation or translation, it doesn't necessarily equip them for, the kind of structured logical reasoning that we see in ReasonFlux.
Yeah. It's like expecting someone to learn how to build a house by simply, reading a jumbled pile of construction manuals, blueprints, and building codes without any clear organization or guidance. Is just not going to happen.
Exactly. And that's where this, structured knowledge approach comes in. By organizing knowledge into these predefined templates, we're essentially providing the model with, a framework for understanding how different concepts relate to each other and how those concepts can be applied to solve problems. It's almost like, giving them this mental scaffold upon which they can build their reasoning.
It's like we're finally starting to bridge the gap between the way humans naturally organize and process information and the way we've been training AI systems.
Precisely. And this shift, I think, has some pretty profound implications. I mean, for one, it can dramatically improve, the efficiency of learning. Instead of, wasting time trying to decipher this chaotic mess of information, the model has this sort of direct access to the relevant tools and strategies, almost like, having a mental toolbox that's organized for specific tasks.
Right. And this organization also aids in generalization, right? So the model can learn to apply these templates to, a wider range of problems, even those it hasn't encountered before.
Sure.
So it's not just about, rote memorization. It's about developing that deeper understanding of, those underlying principles and strategies.
Absolutely. And beyond efficiency and generalization, there's another, I think, really key advantage of this structured approach: transparency. When we can understand how the AI is reasoning, when we can trace its thought process back to these, well-defined templates, it becomes so much easier to, trust its decisions and also to identify any potential biases or errors.
It's such a crucial point, especially as, these AI systems become more and more integrated into our lives. The more transparent and explainable these systems are, the more likely we are, I think, to embrace them as collaborators rather than fear them as these, mysterious black boxes. Now, the paper itself focuses primarily on, math problems, but I think, you both agree that this template-based reasoning approach has far broader applications, right?
Oh, without a doubt. I mean, the potential here is, truly vast. I think any domain where there are sort of established principles, strategies, patterns of reasoning could benefit from this approach. Just to, brainstorm a few ideas, you could imagine applying this to coding. You could have templates for designing algorithms or for debugging these complex programs, or you could think about scientific discovery. You could have templates for formulating hypotheses, for designing experiments, for analyzing data. And I think even creative fields, like writing or music composition, could benefit from this kind of structured template-based approach.
Yeah. It's like we're giving these AI systems access to this, library of expert level knowledge and strategies that they can then apply to, solve problems in ways that we might never have even imagined. The possibilities are, I think, pretty mind-boggling. but maybe let's not get too carried away with the potential just yet. It's important to acknowledge that there are also, challenges and limitations to consider.
Of course. I think one of the, biggest challenges is just the creation of those thought templates themselves. I mean, distilling this complex knowledge into these, structured representations, it's definitely not a trivial task. It requires a deep domain expertise and a lot of careful consideration of, how to break down these complex concepts into these manageable modular components.
It's like trying to write the ultimate guidebook for a particular field.
Yeah.
Capturing all of the essential knowledge and strategies, but in this, really concise and easily understandable way. It's daunting. But it's an incredibly important endeavor, I think.
Exactly. And then there's also the question of scalability, right? As the complexity of the problems increase, the number of templates and the relationships between them, could become increasingly difficult to manage.
Yeah, it's like trying to organize a library with, billions of books. You need a really robust system for categorizing and indexing everything. Otherwise, it, quickly descends into chaos.
Yeah.
And then, there's also the challenge of dealing with situations where, the predefined templates don't quite fit the problem at hand. We can't anticipate, every possible scenario or edge case.
That's right. There will always be situations that require, creative problem solving. Situations where the AI needs to go beyond those, existing templates and come up with these novel solutions. And this is, I think, where that interplay mechanism we talked about earlier becomes so crucial. It provides a way for the model to adapt and adjust its approach based on, the specific nuances of the problem, even if that means, deviating from those predefined templates.
Right. So while, this template-based approach is, I think, a huge step forward, it's not this magical solution that will just instantly solve, all of our AI reasoning challenges. It's a powerful tool, but it's still just a tool. I think the real magic happens when we combine this tool with, other innovative techniques and approaches, and when we continue to, really push the boundaries of what's possible with AI research.
Absolutely. And this paper, I think, is just such a fantastic example of, that kind of boundary pushing research. It's not just about these incremental improvements. It's about challenging our assumptions and exploring, these new paradigms for building truly intelligent systems.
Well said. And speaking of, exploring new paradigms, the paper actually ends with this, fairly provocative thought that I think is worth discussing. It suggests that this, template-based reasoning approach could have these profound implications for the future of, human expertise. What do you make of that? It's a pretty bold statement, to say that AI could revolutionize human expertise. What are your thoughts?
Yeah, it is a really interesting thought. As these AI systems, become more adept at reasoning within these specific domains, using these structured templates to navigate, all these complex problem spaces, it really does make you wonder about the nature of expertise itself. Like if an AI can, for example, diagnose a medical condition or argue a legal case with a level of, proficiency that's comparable to a human expert, how does that change our understanding of what it actually means to be an expert in the first place?
It's like we're kind of blurring the lines between human intuition and experience, which, traditionally have been seen as the hallmarks of expertise, right? And this, more structured, almost algorithmic approach to problem solving that we see in ReasonFlux.
Yeah, and that blurring of lines brings up some really fascinating questions. Could we reach a point, where AI systems armed with these vast libraries of thought templates actually surpass human experts in certain fields? And if so, what does that mean for the future of, education, training, and professional development?
It is, a little unsettling to think that the skills and knowledge that we've spent years honing could potentially be replicated or even, surpassed by an AI. But I wonder if instead of viewing this as a threat, maybe we should be looking at it as an opportunity.
I think that's the right way to think about it. If AI can handle, the more routine, rule-based aspects of a given field, it really frees up human experts to focus on those more, creative, nuanced, and strategic aspects. The areas where human intuition and judgment are still so important. It's not about replacing human expertise. It's about augmenting it and allowing us to push the boundaries even further of what's possible.
It's almost like having, a superpowered research assistant.
Yeah.
One that can, handle all the heavy lifting of data analysis, literature review, maybe even hypothesis generation. And that leaves, the human scientists free to focus on the big picture thinking, the creative leaps of insight, those ethical considerations that are so crucial in scientific advancement.
Exactly. And that kind of collaboration, between human and artificial intelligence, where each one is leveraging, their respective strengths, that could lead to some really remarkable breakthroughs. Imagine a world where, doctors can diagnose diseases earlier and with much greater accuracy, where engineers can design more efficient and sustainable infrastructure, where lawyers can navigate these really complex legal issues with more clarity and precision. I mean, the potential is truly limitless.
Yeah, it's an exciting prospect, but also, I think slightly daunting, this idea of AI not just assisting us, but potentially reshaping entire fields of expertise. It calls for, a really thoughtful and proactive approach to how we develop and integrate these technologies into society.
Oh, absolutely. It's so crucial that we're having, these open and honest conversations about the ethical implications of all of these advancements. How do we ensure that these powerful AI systems are being used responsibly and, for the benefit of all? How do we address any potential biases that might be embedded in, these templates themselves? And how do we prepare the workforce for a future where, collaboration with AI is not just an option, it's actually a necessity? These are some really complex questions, and I think, they require careful consideration and collaboration between researchers, policymakers, and the public.
It's a good reminder that, as we marvel at, all this incredible ingenuity of these technological advancements, we also have to remember that the future of AI is not something that just happens to us. It's something that we actively shape through our choices, through our values, and through, our commitment to using these really powerful tools for good.
Well said. And I think papers like this one, that are pushing the boundaries of what we thought was even possible with AI, those are the essential catalysts for these crucial conversations. They challenge us to really think critically about the future we're creating and to make sure that it's a future where, both humans and AI can thrive.
Well, this has been a fascinating deep dive into ReasonFlux and, all of its implications. I think it's pretty clear that this research is just the tip of the iceberg. We're really at a pivotal moment in the evolution of AI, and I'm really eager to see where this journey takes us next. Thanks for joining us.